All right. When we talk about odd degree polynomials, like y equals x, okay? I think we all know y equals x is a line with the slope of 1. There's really no changes to it. It's a consistent rate of change, okay? But now as soon as we start getting higher odd powers, like x to the third, it's not a line anymore, right? Okay? But here's your y equals x cubed graph. It still is increasing, okay, pretty much the entire time, except right at 0 it does level off for a moment and then starts heading back up, okay? But sometimes it can do a little bit more than that. It can kind of have some hills and valleys in it. It might look something like this, okay? And I could add more to that, all right? But do you see how this graph has two turns in it? So it's going up, 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 hits this hill right here, and turns and starts going in a negative direction, right? So it turned from increasing to decreasing. And then down here, it turned again from decreasing back up to increasing. So it had two turns in it, okay? An x to the third polynomial, or an x cubed, a cubic polynomial, will never have more than two terms. Okay? An x to the third polynomial can never have more than two terms. Now, an x to the fifth and x to the fifth can have more than that. So an x to the fifth is going up, one turn, two turns, three turns, four turns. So an x to the fifth can have four turns. Okay?
Suppose you, however, its highest degree minus 1.
Yep. Whatever its highest power is, the number of turns it could have is one less. Okay? The number of turns a graph can have will always be one less than the degree. Let's talk about even powers. Y equals x squared. How many turns? One turn, right down here at the bottom, right? Okay? Talk about y equals x to the fourth. Okay, y equals x to the fourth. We know that on the ends, both are headed up, but there's one turn, two turns, three turns. Okay? So do you kind of get the whole idea of the number of turns it could have? Yeah. Got a rough idea? Okay? So what I would like you guys to do then is just on your scratch paper, see if you can draw a rough sketch of these 5 polynomials. You don't need to be accurate whatsoever. I just want to see what you guys can do and draw a rough sketch of these 5 polynomials. I'll do the first one with you. Okay? Number 14. I see it's x to the third. The leading coefficient is 1. Okay? So, and there could be as many as 2 turns. So it might look something like that. Just a rough sketch. You guys see how I came to that conclusion? Okay? It's x to the third, so I know the graph kind of looks like this. As I go to the left, it heads down. As I go to the right, it heads up. And there could be 2 turns in it. So there's my rough sketch. Okay? I'm not being accurate on different coordinates or anything at all. Just draw a rough sketch of these 5 functions real quick in your notes. Okay?